Hey there, my name is Alejandro. Welcome back for day 335. We're doing Daily LeetCode challenge that there is 1 year's worth of green contributions here on GitHub. So today's promise for June 16th, 2025. Without further ado, let's get straight into it. Okay, there we go. LeetCode easy. Problem 2016, maximum difference between increasing elements. And this is an attempted easy. Wow, an easy we cannot solve. When was the October 6, 2023. So back when I was starting LeetCode for the very first time, most likely. Okay, well, the very first thing I see is that the word maximum means that this is going to be an optimization problem, which means it's either going to be DP, greedy, or divide and conquer, most likely. So let's read it. Given a zero-index integer array nums of size n, find the maximum difference between nums i and nums j. Okay, such as 0 and nums of I is less than nums of j. Return the maximum difference. If no such I and j exists, return -1. What? Why? If nums is at least... What do you mean if no such I exists? Okay. Oh. Oh, I see. Oh, okay. Okay, well, the constraints are at that, so that's why this is LeetCode easy, because you can brute force your way through it, right? You can probably just do for I in range. So yeah, so here you can do n is equal to length of nums for I in range, n for j in range, I plus 1, comma n. Here we can even just say res equals 0, that way we only consider positive solutions. And we'll say res equal to max of nums of I equal to nums of j. Diff is equal to num j minus num I. If res less than diff, res equals diff. And then return res, right? So something like this is a brute force solution. This is an n squared solution. Ooh, okay. We can do -1 by default, actually. And there you go. So something like this should work just because of the constraints, allowing for an n squared solution. Wrong answer, actually. Output 0, expect a -1. Well, that's bloody weird. What the heck? Oh, it is 0 and expected -1. Okay. Yeah. Res greater than 0, else -1. We'll just do it this way, and that way we have a correct solution. Yep, there we go. Submit. And there we go. Bada bing, bada boom. Completion streak 335 days. Consistency is key. See ya tomorrow. Okay, but yeah. Okay, so we're over here. There's a much faster way of solving this. I presume this. There's probably going to be a linear runtime way of solving this. Yeah, makes sense. Makes sense. Makes sense. Right? Yeah. What I would presume, yeah. So this is like easy O of n squared brute force solution. Let's try to come up with an O of n. And what I'm thinking is essentially we loop through every single index, and as we go along, it's kind of like best time to buy and sell a stock, right? We're just like, all right, keep track of what's the minimum number we've seen, right? And so we do something like res equals 0, very same way. We'll do min num is equal to, we can do float of infinity. Here we'll just say n is equal to length of nums of 0 for I, comma num and enumerate nums. We can even just do float of infinity. It really doesn't matter. We'll just say min if num less than min num equals num. Diff is equal to minus min num, res we want the maximum diff, right? If that's less than diff, res equals diff. All right, then we continue. Return res if res greater than 0, else -1. What about something like this? Yeah, so that works, and I'm guessing this is going to be much faster. And there we go. 0 mass beats 100% of solutions. Bada bing, bada boom. That is exactly what we love to see. Okay. So nevertheless, as always in my videos, the quick recap of visible solved problems. So for this one, we solved it in no event squared, which is like, the very naive, easy brute force approach, because here the problem is we're given an array of integers nums, and we want to find the maximum difference between any two numbers in nums, right? So the very first thing in my mind, I was like, okay, subtract the maximum from the minimum. But there's an additional constraint, right? Because here I saw, like, if there's no such difference between -1, I was like, what the heck? Well, there's at least two elements here. What the heck does returning -1 mean? Well, because there's another restriction that it must be that I is less than j, right? So if the smallest number is the last number and then the biggest number is the first number, you can't subtract them because, the last number's position is not before the first number, right? So, like, if nums is equal to 15, 15 and 1, well, you can't do 15 minus 1 because it is not the case that a 15 comes before like the only subtraction you would be allowed to do is 1 minus 15, right? That's the point. Yeah, and it must also be that nums of I is less than nums of j, which means that it must be that when you do nums of j minus nums of I, that the difference is greater than 0. So that's why in my code here, what I do is I initialize res to 0. At the very end, I know that if res is greater than 0, I can return res. Otherwise, if res is not greater than 0, then the maximum difference I ever found was not larger than 0, which means it was never the case that this property was satisfied. So that's why I returned -1 for invalidity. So in terms of the way that I solved it, essentially, this is kind of like a slider window approach. The brute force way, the n squared way, is essentially go through every single I and j pair where I is less than j, and then be like, if it is the case that also those numbers are that if you're paranoid, you can check this condition out as well. It could just be like, okay, compute the difference, update res, and there you go, and return res at the very end. So the brute force solution is very straightforward. It's the first one I wrote. But then I realized we can just kind of like, almost like sliding window our way through it, very similar to best time to buy and sell a stock from the LeetCode 150 playlist, which is, I think, like the very first easy sliding window problem, where essentially what we're going to do is, okay, since we can only subtract, a number at index j for some index j greater than some index I, and we want to maximize our difference, which means we want nums of I to be as small as possible. So how about we go through nums from left to right, and as we do so, we keep track of what is the smallest number I've seen, right? Because, nums of I, I'd like to minimize it as much as I can, right? And if it's the smallest number, then, the higher the chances that, nums of I is less than nums of j. So what I'm going to do is I'm going to say, okay, n is equal to length of nums, res is equal to 0. I'll tell you why I initialize res equals 0. Well, I already have told you. The point is that if I never find a sum that's a maximum difference that is greater than 0, right? That means it was never the case that some nums of I was less than some of the nums of j, right? Which means that there was no difference. So at the very end, I'll say return res if res is greater than 0. Otherwise, return -1 because there was no solution. So here what I'm going to do is I'm going to keep track of a minimum number, the minimum number I've seen. Initially, I just set it to infinity, right? Some nonsense value. Just don't make it negative infinity because then no number is going to be smaller than negative infinity, but every number is smaller than infinity. So here we're going to go through nums from left to right. So for I, num and enumerate nums, where I is the index and num is the number. We're going to say, okay, if the number is smaller than the current minimum number we have, update the minimum number equal to num. Now, compute the difference between the current num and the smallest num that we've seen so far. Notice that if we went through this, then min num is equal to num, and this difference would be 0. But when we update res from 0 to 0, nothing happens. And again, we still know that we haven't found one where nums of I is less than nums of j. So we're going to take the difference between, so we first update the minimum number in case it's smaller. Right, if you really wanted to, you could put a continue here, and it wouldn't affect anything, right? I just didn't bother. But here what we're going to say is diff is equal to num minus the smallest number we have seen so far. And if res is less than diff, right, which res is initialized to 0 initially, then we're going to update res equal to diff, right, which means that res will no longer be 0, which means we've found a solution that's at least 1, and we're going to keep going until we find the maximum difference. So the point is that this is kind of greedy in nature, where we're going to go through the numbers from left to right and keep track of what is the smallest number we've ever seen so far. And as we do so, as we go through every single number, we're going to be like, okay, how about the current number minus the smallest number we've seen so far. Get that difference and update res if that difference is larger than what's currently stored in res. Do that for every single number, and at the end, you'll end up having your maximum difference. Now, if res is still equal to 0, that means you never update it with a difference that was greater than 0, which means it was never the case that some nums j was greater than some nums of I for some index I less than j. So if res is not greater than 0, we return -1. Otherwise, we return res because that's the maximum difference that we found. And there we go, bada bing, bada boom. We have a nice and efficient working solution to this problem. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, and in shape or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So until then, ciao, ciao, my friend. Bye-bye.